Okay, so metric sequences here. And geometric sequences are very different than what we've been doing. So for example, here is a nice geometric sequence, 1, 2, 4, 8, 16, 32. We basically got a common ratio this time. We are always multiplying by 2. So there's nothing arithmetic, quadratic or cubic about this sequence. It is a geometric sequence. So remember, that's the first thing you have to do is recognize that it is geometric. Okay, you might get one that looks like this. Change color. 3 minus 9, 27 minus 81. This is geometric as well, because the common ratio is minus 3. I'm always timesing by minus 3. So the common ratio may be negative as well as positive. Okay, we can always find out what the common ratio is by just doing one number divided by the number before it. One number divided by the number before it. One number divided by the number before it. That's what that is saying. Take a number and divide it by the number before it. Okay, I hope that makes sense. Now, let's talk about what the nth term of a geometric sequence is. Let's just think about it logically. Let's say we have any geometric sequence that starts off with a first term, and let's call that first term U1. That's the first term. The next term is going to be U1 times whatever your common ratio is. Let R be the common ratio. Then the third term in the sequence is going to be U1 times R, and then times by R again, so that's going to be R squared. The fourth term is going to be whatever your last term was, so that's U1 R squared times another R will be U1 R cubed. And you can see the pattern that is emerging. So the nth term is going to be U1 times R, and notice this one is always one less than the position. 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 So that's U1 times R to the power of n minus 1. Okay, so the nth term of a geometric sequence is always the first term times the common ratio to the power of n minus 1. Okay? So here are some basic ones. Can we find the nth term of each of these? Well, are they geometric? With this one, yes, A. It says A. It has U1 is equal to 1, and R, the common ratio, is equal to negative 1. I'm always timesing by negative 1 to get to the next one. So what is the nth term? UN is equal to 1 times negative 1 to the power of n minus 1. Okay? For B, it's exactly the same. U1, always just identify what the first term is. That's really easy, just read off. And then find the common ratio. Again, that's minus 1. So UN is equal to minus 1 times minus 1 to the power of n minus 1. And you may actually, if you're really good with your rules of indices here, you might notice that that's minus 1 times minus 1. Well, that's actually equal to minus 1 to the power of n. Okay, because the rules of indices say this would become minus 1 to the power of 1 plus n minus 1. So the 1's cancel out, you're left with minus 1 to the n. So if you're really good with your rules of indices, you would have spotted that. What about, let's do E. E has a U1 equal to 6 and common ratio equal to 3. I'm always timesing by 3. So U of n is equal to, first term, 6 times 3 to the power of n minus 1. Then let's do F. U1 again is equal to 6, but this time R is equal to negative 3, because you're always timesing by negative 3. So UN is equal to 6 times negative 3 to the power of n minus 1. Okay, and just a little additional question for you. Let's just do 6 times 3, oops, 6 times 3 to the power of, let's do that. Okay, let's say we have a number. Let's just get rid of this. And the number in that, the number is 13,122. What I'm saying is that belongs in sequence E. What position is it in? Well, all I'm going to do then is I'm going to say 13122. When is that equal to the nth term? And then I can find out the appropriate value of n. Well, how do I solve that? Let's divide both sides of the equation by 6. So divide that by 6. I'm going to get 2187. Now, how do I solve that? Really hoping that you recognise that is logs. So n minus 1 is equal to log base 3 of 2187. Use a calculator. Log base 3 of 2187 equals 7. So n minus 1 is equal to 7. Oops. So n is equal to 8. So this number here will be in the 8th position. So there we go, logs coming back into it again. All right? So please remember that the nth term of a geometric sequence is the first term times the common ratio to the power of n minus 1. Okay? You just have to remember that, and then you should be able to use it easily enough. Okay? Right.